In this video, we're going to see how trig can be connected back into some of our older topics from the year. So first, in this first exercise, we have parallelogram ABCD has the vertices given and determine the measure of one of its larger angles to the nearest degree. So let's first plot these points. So we're looking at 1, 4, 9, 4, 4, -3, and -4, -3. Now keep in mind, we definitely can tell it's a parallelogram just by the look of it. With this unit, we want to find an angle measure. Now, we can't find an angle measure from anything with coordinate geometry or anything from the graph, but you may recall here what we've been doing recently is working with trig. So we're going to be working with the right triangle here. Now, we have to make a right triangle somehow. So I'm going to draw in here an altitude because it's from one side to the other. It's the height, and I'm going to make this the right triangle that we're dealing with, because then what you might notice is I can count the lengths of the two sides here. So I know that we have 1, 2, 3, 4, 5 units on the bottom and 7 units up. So I'm looking at a right triangle here. Now I could go and I could do Pythagorean theorem if I wanted to find the length of the hypotenuse, but I don't need it because I can find one of the angles right now. So that's what we're going to do. I'm going to find angle D here. So if I'm going to find angle D, 7 is the opposite side while 5 is the adjacent. So we're going to use tangent. Tangent of D is equal to 7/5. So remember, when you're looking for an angle, we do the inverse of the trig function in the calculator. The calculator should still be in degree mode. So second tangent, 7 divided by 5, and we get 54.4623. Okay, and to the nearest degree, that's 54 degrees. Now, we're not quite done just yet, because we wanted to determine one of its larger angle measures. So we're going to look at our picture here for some guidance, because if we want the larger one, angle D is definitely an acute angle of 54. So what we should remember about parallelograms is that the consecutive angles, so like D and C or D and A, one after another, are supplementary, meaning they add up to 180 degrees. So we're going to take 180 and subtract the 54. So we'll get 126 degrees. Okay, so that could be angle A or C in this case. Bringing back quadrilaterals again, if we had a rhombus DEFG, the common side length is 18 inches and the smaller interior angle has a measure of 68. What is the length of its longer diagonal to the nearest tenth? Okay, so I would recommend we draw ourselves a picture here. We don't have a graph to go off of, but remember, we're drawing a rhombus, so you may recall that all the sides are equal, which is why it said the common side length is 18 inches. So all four of these sides are 18. And we were also given that the smaller interior angle has a measure of 68. Okay, remember opposite angles are congruent, so that's why I had 68 in both of those smaller spots. We could also find the other degree as well if we wanted to. But our goal is to find the length of the longer diagonal. So what I need you to keep in mind here is that we want to find this diagonal here, but we can only find it if we're using trig with a right triangle. So we have to recall that the diagonals in a rhombus are perpendicular. Now, in this case, we also have to remember an important quality about the diagonals. They bisect the angles. So we know both of these angles are 34 because it cuts that 68 in half. Now that is strictly a rhombus property, but then we could take one of the right triangles, and I'm going to draw it over here on the side. So we know the hypotenuse, the angle across from the right angle, is 18. We have 34. And we're trying to find the longer angle here. So if I'm trying to find that longer diagonal, I'm going to find x. Okay, so now that we have this set up, we're going to go ahead and solve for x. Remember, in this case, we have the hypotenuse. We don't have the opposite, but we're trying to find the adjacent. So from our phrase, SOHCAHTOA, we are going to use cosine. So cosine of 34 is equal to the adjacent over the hypotenuse. We can stick this over 1, and we'll cross multiply. And when I go to my calculator now, 18 cosine of 34, and we get 14.9226761. Now, it said to the nearest tenth, but keep in mind of one thing. We solved for this piece here. We want the length of the entire diagonal. So remember, the diagonals bisect each other, which is also known as cutting in half. So I'm going to go right to my calculator and multiply this by 2. Okay, and so I don't want to round too soon because I don't want to be thrown off even by a decimal place. One slight decimal could really throw off my answer and I would lose a point. But now I'm safe to round to the nearest tenth, so 29.8. And I'll add the unit in there because it told me inches. Okay, now we're also going to be looking back to some of the trig problems we were dealing with, but we sometimes have to do trig more than once to get our whole answer. So in this case, we have a tower is located 327 feet from a building. It's shown in this picture below. A person from the second story has an angle of elevation to the top of the tower, making 32 degrees, and an angle of depression to the bottom of the tower, making 18 degrees. Find the height of the tower. So what we have to recognize here is we need a right triangle. So we have a right triangle here, and we have a right triangle here. So in this case, I'm going to have to find this piece x, and I'm going to have to find this piece y. And once I find the two pieces, we can get the whole thing by adding them together. So let's start with that pink triangle that I highlighted here. So we know that this is 327 for both of them because it's the distance apart. So from this angle of 32, I'm looking for the opposite. I have the adjacent. There was no mention of anything with the hypotenuse, so that means I'm dealing with tangent. Tangent of 32 equals x over 327. So x is equal to 327. Tangent of 32. Now when I plug that into the calculator, 327, tangent of 32, 204.3322781. So that's our first piece there. We're going to do the same thing here for this blue triangle. So again, we're looking for the opposite, and we have the adjacent. Nothing about the hypotenuse, so it's tangent again. But this time it's tangent of 18 is equal to y over 327. So we cross multiply, we get y equal to 327 times tangent of 18. And we get 106.248747. And then that last piece is to add those two pieces together. So we got x, we got y. We're going to get x plus y. And I'm going to let the calculator handle this for me. So remember, I can always hit the up arrow and highlight that 204 plus that up arrow and highlight here. And we get 310.58101. And I'm going to check back to the nearest tenth of a foot. So we're looking at 310.6 feet. Remember that 8 rounds the 5 up. Okay. And let's look at this final question together through exercise 4. We have a person with a kite, and they have let out more string. We have the angles of elevation shown, but we want to know how much higher the kite is at B than C. So we're looking for this piece here. But I can't find that because if I look, this isn't a right triangle. So what I'm going to have to do first is do the whole triangle and find this piece. And then I'm going to have to take this right triangle, and then I'm going to subtract this time. Triangle and the purple triangle, and I want you to try to set up the trig functions first. So go ahead and pause the video and set up the trig functions, and we'll see if we match. Right triangles just to get a picture of it a little bit clearer, but we use sine because we were trying to find the opposite and we had the hypotenuse. So I found both the pieces, x and y. The last thing to do is subtract these two values, and to the nearest foot, 34 feet.